Hey everyone, welcome to the Let's Create series, a series where we'll create mechanics from popular games using blueprints. Today we'll be covering Tracer from Overwatch, and we'll be focusing on her recall ability. If you're new to the series, make sure to watch my Let's Create Foundation video before starting this lesson. Let's get started. So the same thing as last week when we did our super hot tutorial, we're going to take our FPS controller and duplicate it. And this time we'll be calling this Tracer controller. And before we begin editing Tracer, we need to go into settings, project settings, and we need to set up an input for her recall ability. So we're going to go back down to input, action mappings, and this time we'll call this recall. Actually, we'll just call this ability because we might use this mapping for other characters. We'll just map this to E on the keyboard, and then we can close this. So this blueprint can get a bit complicated, so I'm going to try and explain it as best as I can. And to start off, what we need to do is we need to save our transform. The reason we're saving our transform is because transform can store both our rotation and position, which we can then access later on. We are going to use the event tick in order to do this. So event tick runs every frame, and you can run multiple things at once using a thing called sequence. We're going to need a few variables for this. So the first one I like to set up is our delta time. Now delta time allows us to run all of our nodes at a set frame rate, if you want to consider it that. So instead of relying on your computer's frame rate, which can cause physics bugs, we're going to use delta time. Next, we're going to set up a sequence. And the reason we want a sequence is because this function we're going to create, this bunch of nodes we're going to create, it's first going to track our positions. And then if we press E, it is going to move us to all of these positions and also change the rotation of our character according to the rotation of the position set up here. So we also need another Boolean, we need another variable, and this is going to be Boolean called canSetPos. And the reason we need this is because we need to check a condition, which is again a branch. And what we need to check in this branch is if we can set our position. Whoops. If we can set our position. By checking if we can set our position, we can also not check our position. When Tracer is using the recall, we do not want to be tracking her position because we can save some of the game logic and we don't have to run all of these nodes that we're going to set up here. Also, it can cause problems if you're setting new nodes whilst using Tracer's recall, because it will attempt to go to the nodes you've just created. After you do a branch, we need a delay node. And the reason we want a delay is because we want to only set new positions every few milliseconds or seconds. In this case, let's try 0.6. So we're going to set a new position every 0.6 seconds. If you want to be a bit more official with this, we could call it time before setting a new position. We could then make this a float, and we can plug that into here, get, and put that into there. We can make this editable, which means you can change it in the editor, and we can just set it to 0.6 in here. So that's a lot nicer. Now, the way we're going to be tracking all our positions is through an array. So let's create an array, and we're going to call this recall positions. Now, in order to create an array, you need to click on this little icon here and click on array. We also want this to be a transform array. Now, what an array does is an array can store a bunch of values that you can go through. We call them indexes. So from 0 to however many you need, 0, 1, 2, 3, 4, 5, etc. What we can then do is iterate through each index of the array. So each index will actually be a position and a rotation. And we can iterate through each index, and then we can move from index to index, which is really moving from position to position. With our array, what we need to do is begin adding things to the array. So what we want to do is create a branch here. And the reason why I want to create a branch here is because if we keep on adding things to the array, at one point we need to begin removing things. So we'll get to the removing part in a second. Let's just begin on adding. So when this condition, which I have already planned ahead of time, when it's false, we want to add. And you see array here, add. Now add requires an array, and it needs something here. In this case, our array is a transform. So this is asking for a data type, and this is asking for an array. We're going to get our recall positions and plug that into add. Now it is wanting a transform data type. And in order to do that, we're going to get our actor transform, and we're going to put that into the add. After this, we also want to display and debug our position so we can visually see it as game developers. So we're going to use something called draw, debug, position, or point. And then we need to add in a position. So in order to do that, we need to get the array. And remember before I said we can get an index of the array, which is 0, 1, 2, 3, 4, 5, etc. We want to display the various indexes in the array. So by getting the index from the array and putting it, I think it was draw, did I get that right? Draw, debug, frustrum. Sorry, wrong one, frustrum. By getting each position in the array and the particular index we want, we can draw them, and we can set a color, duration, and how big they should be. So we're just going to make them orange so they stand out. We're then going to set a delay of, let's say, 6 for now, and then we'll make the thickness 15. We'll then plug in add to here. And now what we're doing is we're adding positions, and we're also drawing them on the screen so we can see them ourselves. Now, the thing I mentioned before is if we're continuously adding, at some point we need to get rid of a few of the positions in the array. In order to do that, we need to use recall positions again. So recall positions. And we're going to use something called a reroute node, which is really nice. So I'm just going to drag this here. Whoops, reroute node. And it's just going to make our blueprint a lot cleaner. And what we're going to do is get the last index. Last index is the very last position, in this case, that we have stored. And we're going to remove the last index. Oh, sorry, not the last position. It's the very last, it's kind of, if we have 0, 1, 2, 3, 4, 5, it's going to remove 0, and then 1 will become 0. That way the oldest position will get deleted from the array. We're then going to, with this last index, do that deleting thing I mentioned by using remove index. And you'll notice here it requires an array as well. So we're going to plug that into there. And it also requires to be activated. And the only reason we remove it is when this condition is true. Now, let's work on this condition here, which we can do because we have recall positions. In order to know when we want to get rid of an index, we need to get the length of the array. And when this array length is greater than a value, then we can delete one of the values. So in this case, we're going to do greater or equal to integer and plug that into here. this value, you can set it to what you want. So if I set it to 3, it will delete every third entry. If I set it something like 6, it's going to save 6 entries and then get rid of one, save another one, get rid of one. I'm going to set it to 8 for now. And I think it's best to actually test this and discuss what's happening through testing it. So I'm just going to put this to the side for a second, hit play. I better double check that this is functioning. Oh, and we need to set can set position to true from the start. That's a boolean I forgot to tick. That's why it's not actually running through our sequence here. So just save that, make sure you set that to true. Let's see what's happening. Oh, one other thing I forgot. We actually have to set our FPS game mode. So we need to go into the Superhot controller and make this the tracer controller. So you probably figured that out before I did. So make sure you change that. And now we have these position saving, these transforms. And after there's 8 of them, you notice it begins deleting. So it depends on how far back you want Tracer to be able to recall. And it's storing this array as we move around, which is really cool. It stores it the different heights, so it stores these different transforms that we can move between. And that's the logic of how we can store these transforms. Now that we have the logic, whoops, go to the tracer controller. Now that we have this logic set up here, what we need to do is actually get a recall input. So when we press E, we can initiate recall, and then we can continue this branch here. So what we're going to do is first get input, action, and then we're going to get ability, which is E. And when ability is pressed, we need to do a few things. Now, in order for the player not to spam recall, we need to do a condition again. And this condition is going to be a boolean called can recall. If can recall is true, that means you're allowed to recall. If can recall is false, that means it is currently on cooldown. Then what we need is another variable called recall pressed. And recall pressed allows us to track if the player has pressed recall, which is going to stop this logic from occurring up here. Then, oh sorry, it's going to, yes, sorry. It's going to allow this new logic, you'll see in a moment, it's going to allow this branch to occur. You'll see, I got it mixed up for a second. The next thing is can recall, which we will set to false. So we check if we can recall, then we set it to false. And then the next thing is one more boolean. Oh, actually, no, we already have it. The last one is can set position. And that stops it from continuously setting positions whilst we're recalling. The very final thing we want to do is set, oh, we'll actually do that bit after because we haven't done that logic. So save that. We'll comment this for now and we'll call this recall input. Now that we have our input set up and the logic of saving, what we're going to do next is begin on this next branch where we can actually recall. And this is going to be a little bit complicated. So first of all, we need to drag this down and we want to create a branch. And what we want to check is if recall has been pressed. So we're going to drag this here, recall. So we drag this here, get, recall pressed. And because recall is pressed, we can then begin using set actor location And now we can get a new location and move our character to this new location. This is going to be a bit of a setup, but it's going to be well worth it. And before we go any further, we need to use a counter as an integer, and I'll explain why once we get to that section. Okay, so we need to lerp transform. So in order to do that, we're going to type in lerp, and we want to get the lerp transform. We then want to split this struct pin so we get a location, a rotation, and scale. We're going to then plug in the location into here. A lerp allows you to move smoothly between two locations. So the first location, you want to get your get actor transform. So that's the position you're currently at. You then want to get the recall position that you want to move to. So we're going to get recall positions, get, and we're going to move to whatever recall position index we put here, which we will set up in a moment. We then want to add one more variable, and we're going to call this travel speed. We're going to make this a float, and then we're going to drag these out here. We're going to add travel speed, get, delta time, get, and we're going to times these together to make our alpha work with delta time and based off whatever speed we want. Let's try just a speed of 6 for now, and delta time is already going to be set as we did up here. Okay, the next thing we need to do is we also want to set a rotation, which will be set control, whoops, sorry, we need to get player controller, and then we need to set control rotation and plug this into here. And we're going to use the same logic up here, but we're going to do it a bit differently. We're going to use a rotation lerp. So we're going to type in lerp, and there's a rotator lerp, which is really nice. We're then going to plug in the return value into here. And the rotation is based off, so based off here, we get our transform. In this case, we drag off here and we get actor rotation. And then we drag that into A. For B, we need to get our lerp rotation, which comes from our array, which is really nice. So we're going to get our rotation, which is coming from here, and we're going to plug that into B. And we're going to do the exact same thing we did here. So we're going to copy this, drag, Control C, Control V. We're going to plug this into here, but now we're going to create a new variable. So instead of travel speed, we're going to call this rotation speed. We are then going to drag that here, get, plug it in here, and we'll just set it to something like 4 for now. And then we'll make these editable so we can change them in the editor. Okay, nearly there. The next setup is we need to actually figure out what this number is. And this number is going to be counter. Counter is going to, actually, I'll show you what's going to do through the code. It'll be a lot easier. We're going to make sure if counter is equal to 0, we're going to use a branch and plug this in here. And what we're going to do is counter is going to be set up down here. So counter will make a lot more sense once we set it up. So we're going to get set, drag it there. We're going to get recall positions, and then we're going to get last index, which remember is the very last thing that was inputted. We're going to drag that into counter, and what's going to happen is when we press E, we're going to set counter. And counter might, let's say we save 6 positions, counter would then equal 6. What will happen up here is it will get the 6th position and then it will go through and it will set our location and rotation to that 6th position. With our code here, we're going to minus counter, so it goes to from 6th to 5th, 4th, 3rd, 2nd, 1st, so you can move from every position in the array, from 6, 5, 4, 3, 2, and 1. So here, if that is equal to 0, oh, sorry, wrong one. Break this. This is for another branch. So we'll get a branch here, and I'll show you what this does in 1 minute. We'll just add a reroute node to make that a lot nicer. And we'll just drag that into there. I missed one important step, which is when you move to a location, sometimes it's not, we need to actually check if you are at that location. In order to do that, we're going to use something called nearly equal. And what nearly equal does, we'll just plug it into this branch here. Nearly equal checks A and B. In this case, our actor transform, whoops, get actor transform. And then for B, it's going to check our array get. So let's make a reroute node and plug that into B. So what's going to happen here is it's going to check if we're close enough to our transform, if our transform is close enough to the array transform. Now tolerance is how tolerant it will be, how close you have to be. I found these values worked really well before. You might have to mess around with these. Now, what's going to happen is if we are close enough to our location and rotation, it is then going to branch through to this branch here. Then in this branch here, we're going to, just drag this over here, if our counter is not equal to 0, which means it might be at 6, 5, 4, 3, 2, 1, we need to use a minus, so a decrement float, and we need to, integer, decrement integer, we need to minus from our counter, so it can continue iterating through this, and we're creating like a mini loop here, where it will keep on decreasing it until it reaches 0. However, if it has reached 0, we want to reset everything. So that means we need to make can set position true again, which allows this function to run, this branch. And then we need to set recall pressed to false. And then what we want to do is we want to clear the array. So we have none of the previous positions tracked, and that means this function, this bit of blueprint up here can run without any previous data. We then want to add a delay node for around 6 seconds, and then we want to be able to allow the player to press the recall button again. So think of this as this is the cooldown timer, and this lets you press E again. Okay, that was a lot. So let's see that this actually works before I go on any further. So we've got all these here. Press E. Might have missed something. So let me just double check that this is working down here. So to see that this is not running, so I'm just going to double check my settings, project settings, my input. Ability is mapped to E. Can recall. Oh, needs to be set true from the start. And there we go. We now have traces recall done. So you have to wait for the cooldown, you press E, and then you go between each of the positions. It's really cool. This took me so long to figure out, guys. It really did. I'm really happy that it worked out on camera. Okay, so this is huge. Let's comment this one out. So just drag over it, press C, tracer. Whoops, I pressed too many buttons. There we go. Oh, tracer recall ability, awesome. Okay, so I'm just gonna briefly go over that one more time because it's a lot to take in. So down here, we press E, then we check if we can recall. If we can, we set it so the recall has been pressed. We set it so we can no longer recall, and we set it so we can no longer track positions, so it doesn't mess around with our indexes, so we don't add any more to our indexes. And then we set counter to equal the last index so we can iterate through it. Up here, all this here, I explained it before, it just tracks your position. And this down here, we're mainly focusing on lerping our rotation and location. And we do that based off the value of the recall, the index of the recall position. This counter allows us to iterate through each index until we reach 0. Once we reach 0, this code no longer functions, and the player goes back to be able to move around again, like normal. Okay, oh, that was a lot. I hope everyone got something out of this, because that was a lot to go through. If you enjoyed this video, or any of my other videos, I actually am starting up a Patreon now, so you can support me. These videos take a lot of time, a lot of effort, not just the Let's Create, but every other series that I'm trying out. And I'm really excited to try out all these new series because it allows me to expand and teach you guys more things, and it allows me to show off a bit more about game development. So it's not just about blueprints, it's also about the mindset of developing games. It's about, like, you're going to need technical knowledge, and you also need some other types of knowledge about maybe marketing, or you need knowledge about game ideas, or not overthinking things, or you need additional resources like in Resource Drop. So this Patreon is about supporting all of the content so I can help you guys grow, and in return it helps me. So once again, thank you so much for watching all of my videos. I hope you got something super useful out of this, and remember, pursue what is important to you, because impossible is just a mindset. I'll see you in the next video.